domain and range. And specifically, we're going to look at different given problems, whether it's ordered pairs, graphs, equations. How do you find domain and range on each one of those? So what is domain and range? Domain is your x values. They're shown on your x-axis of your graph, and it's a set of all possible input values, things you can plug into your equation. Your range are your y values. They're shown on your y-axis of your graph, and it's a set of all possible outputs. So when you plug in something for domain, you're getting out the range value. So for functions, each input has a single output. In other words, when you put in an x into the equation, you're only going to get one y value to come out. If you get more than one y value to come out, then it's not a function. So the definition of function is one thing in, one thing out. Now, if you're looking at a list of ordered pairs, you're also looking to see where x's don't repeat. It's the same idea, one x in, one y out. And if you're looking at a graph, we could use something called the vertical line test, where you take your pencil or your pen, scroll across your graph in a vertical line. If you ever touch the graph more than once, it's not a function. If you only touch the graph one point at a time, you have a function. So we're going to look for those three things. We're going to look for domain, range, and functions from different types of problems. So let's start with ordered pairs. Keep in mind, ordered pairs are always in the form x then y. So when we're being asked for domain and range, domain will be those first values in the ordered pair, range is your second values. And when you're looking to see if something's a function, you're looking for x's to not repeat. So here's our example. List the domain and range values for the given ordered pairs below, and then determine if this set of ordered pairs represents a function. So for the first one, domain, we're looking for all of our x's. So we have 3, 2, 3, and 4. Those are all of our x's in the front. Then we can look for our range values. We've got 6, 8, 0, and 4. Those are all our values in the back of our ordered pairs. Those are our y's. Now the last thing, determine if this set represents a function. Go back to those x's, so the ones that are currently underlined, and if they ever repeat, and like ours right here, we had a 3 repeat, this is not a function. If any x's repeat, it is not a function. So let's look from a graph point of view. If you're looking at a graph, your domain is still your x values, but what you're going to visually look for is the stretching of your graph to the left and the right. When you're talking about range or your y values, you're going to look up and down on your graph. How far down, how far up does it go? If your graph ever continues on past the screen with arrow points, then you're going to use positive or negative infinity to describe the continuation of that graph. When they want us to write domain and range for graphs, we're going to put this in interval notation. We're no longer going to just list out the variables or list out the values like we did with ordered pairs, because there's all those decimal pieces in between. So if we include a spot and we go to a number and we include it, make sure you're using brackets. And if it's ever a spot that's not included, so you might see an open circle, or if it continues on to one of our infinities, we'll use parentheses for that interval notation. And then we'll use that vertical line test to check to see if it's a function. So we have a graph on the right, and our example says, list the domain and range values for the given graph above. Determine if this graph represents a function. So the first thing we're looking for is domain. How far to the left and to the right does our graph go? So because this is a parabola, it has this shape where it looks kind of like a U, but notice that it keeps getting a little bit wider and a little bit wider to both directions. As it keeps moving, it's getting wider. So because of the arrow points at the top, it's still getting wider even off our screen. So it's going to stretch all the way to negative infinity for our x values, all the way up to positive infinity. It's going to keep getting wider and wider as it goes. Now for our range, we are looking for our y value. So how far down, how far up on the graph. Now with a parabola, you will have a definite point involved here because there is that point on our graph here where we go down, we curve, and we keep going back up. So this is the lowest point of our graph. It never is going to dip back down. So this point, you're looking for your y value of it. We go down as far as -4, and we do touch it. So we are going to use a bracket. And then as far as the top of the graph, it's going, it's going, it's going. So we're going to go up to positive infinity for range. So you'll notice when you're doing parabolas, you tend to have lots of infinities involved here because it's extending beyond our graph. But you will always have one spot that is going to be a definite number. Now the last part of this question is asking if this is a function. So I'm going to clear off my doodles on the graph and remind you that for vertical line tests, you're going to take a bunch of vertical lines and cut through your graph. Now it's hard to see because I don't have a pen that can scroll across your screen here. But if you take a bunch of vertical cuts of the graph, notice every time I did that, I'm only touching the graph at one spot at a time. So as long as you're touching the graph one spot at a time, then it is a function. That is your vertical line test definition. Things that are not a function, just so you have an idea. So things that are not a function are sideways graphs. So maybe if it was a sideways parabola, because you're going to cut the top and bottom at the same time. Any shapes that are fully closed in. Anything that kind of wiggles back and forth, where again, there's a top and a bottom to any spot. That would be not a function, or a true vertical line, because you would hit the whole line at the exact same moment. So what about from equation form? Again, domain is your possible input, range is your possible output. For nonlinear equations, make sure to check for domain for values that would create undefined results. So if it's not a linear equation, look for those things that would cause the equation to make zeros or be an error on your calculator. And then again, for vertical line tests, that's really helpful when you're trying to think if something's a function or not. So if you can kind of think of what the graph would look like, you can kind of scroll in your mind to see if it would pass as a function. So we've got 3 examples for this. This is our first one on this page. It says, list the domain and range values for the given equation below. So looking at the equation, y equals 2x plus 3, this is a line. This is a linear equation. So without sketching it, it's going to look something like this. It's going to be going uphill across your graph. If you try to find domain and range of that on a graph, there's no limits for domain or range. So for domain, you could plug in any number at all, negative infinity to positive infinity. For range, you're going to get all the outputs, negative infinity to positive infinity. And if you checked it with that vertical line test, it is a function. So we're good to go. The ones to watch out for are equations that have more going on. So anything with a square root, or if you have a fraction with a variable on the bottom. So here's our other 2. This top one, y equals the square root of x minus 2. Now, if you don't know what this graph looks like, it looks like this. It has a starting point, and then it kind of rises up quickly and then kind of balances out and keeps on going to the right. That's the basic parent function for the square root of x. So what that means is we are going to have a limit, though, on our domain and range here. So whenever you have a square root, the shortcut for this is you're going to take whatever's underneath x minus 2, and you're going to set it greater than 0. So if I solve it for x, I can add 2 over, or you know what? It's greater than or equal to 0. Sorry, put that little or equal in there. X is greater than or equal to 2. Now what that means is those are the x values that I can plug in. I could plug in 2 and get an answer. I could plug in 3 and get an answer. I could plug in 4 and get an answer. So my domain is all the values from 2 up to positive infinity. I can plug them all in. But try it. Try on your calculator real quick if you plug in something smaller. If you plug in a 1 or a 0, you're going to get an error on your calculator. Square roots can't do negative numbers. Now, if they ask you for a range, you can plug in your smallest value, so in this case, the 2, the square root of 2 minus 2, square root of 0. That means our answer is going to be 0 up to positive infinity. Those are the types of outputs we can expect. Positive answers coming out. And looking at our little graph over here on the left-hand side, this is a function. This is a function graph. We can scroll through it with a bunch of vertical lines, and we only touch it at one spot at a time. Now the last one, list the domain and range for the equation here where we have 2 over x plus 3. If you ever have an equation with a fraction, variable is in the bottom. There's a shortcut for this one as well. So just like with the square root, we set it greater than or equal to 0. This one, we're going to take the denominator and set it not equal to 0. The reason for that is if we plug in something and the bottom of your fraction ever becomes a 0, you get an undefined answer. It's kind of like a no solution, but it's called undefined, and it's a dead end. That's not a thing we can graph. So if we solve this for our variable, this gives us the one value that doesn't work for domain. Every other number works. Positive numbers, negative numbers, 0, just not this one. This is the only one that doesn't work. So when you go to write that with domain, you're actually writing 2 interval notations here because it's negative infinity all the way up to that negative 3. But we're going to skip it. So that's what the union in the middle is. We're going to skip over that spot and go from negative 3 to positive infinity. So this symbol in the middle is called a union, which means or. So that means our domain could be either this or this. So we stitch them together. It's just skipping that one number in the middle. Now, if we want to know if this is a function, it is. If we graph this one, it would also be a function for us.